Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA Physics Paper 1 Higher Tier from 2025. This is the separate science of the triple science physics. This paper is 1 hour 45 minutes long and it has 10 questions. Question number 1 is on the topic of energy. Tidal and wind are two renewable energy resources. Describe the difference between renewable energy resources and non-renewable energy resources. Well, renewable energy resources can be replenished, whereas non-renewables cannot be replenished. So, energy resources. Be replenished, meaning that it can be replaced. Well, non-renewable cannot be replenished, but I would actually use the word finite, meaning that it will run out one day. But you can't simply say that it will run out. But you can say they are of limited supply. Figure 1 shows a new design of tidal turbine to generate electricity using the tides. Use the physics equation sheet to answer questions 1.2 to 1.3. Write down the equation that links density, rho. So density equals mass over volume. You can write the symbol equation. The mass of seawater passing through the tidal turbine each second is 824,000 kilogram. The density of the seawater is 1030 kilogram per meter cube. Calculate the volume of seawater passing through the turbine each second. So since density equals mass over volume, if I substitute it, 1030 equals 824,000 divided by the volume. Volume equals 824,000 divided by 1030. That gives me 800. The answer is 800 meter cube. The speed of the tide or the speed of the wind past a turbine is called the flow speed. Figure 2 shows how the power output of a tidal turbine compares with the wind turbine for different speeds. So the tidal and wind. Now, looks like the tidal has a bigger power output when the flow speed is at 1, at 20, and the wind turbine, the flow speed has to be double, but it produces about 16.5. All right, let's see. As flow speed increases, power output increases. Give two other conclusions that can be made using information from figure 2. So now looking at the graph, if the flow speed is less than 0.25, then the power output is 0. So at very low flow speeds, let's say below 0.25 meters per second, there is no power output. Now, the other thing that we can say that the tidal power is always greater than the wind turbine. So tidal power output is always greater than wind power for the same flow speed above 0.25 meters per second. The other thing that you can say is that a change in the flow speed for tidal power makes a big difference than a change in the wind flow speed, because the line is actually much steeper as well. Right, let's have a look at the next question. Figure 3 shows how the turbines used to obtain the data for figure 2. You have a 100-meter diameter wind turbine, a 10-meter diameter tidal turbine, which is 10 times smaller. Right. Compare the environmental impacts of the wind turbine and the tidal turbine. Now, environmental impacts for the wind, they are very big, they can be noisy, and they can harm birds. Tidal is not noisy because it's underwater, doesn't harm the birds but may harm the fish. Wind turbine might not harm the fish. In terms of noise pollution, there's no noise pollution with the tidal, but in terms of visual pollution, wind turbine has visual pollution, whereas the tidal, there's no visual pollution. And because it's big, it needs probably more construction materials. So here's a model answer for this question. Wind turbine is much larger and causes more visual pollution than the tidal turbine. Tidal turbine is hidden from view and is less likely to cause noise pollution as it is underwater. Wind turbine needs more raw materials for construction as they are bigger. More wind turbines are needed for the same power output at the same flow speed. Wind turbines will harm birds, whereas tidal turbines will not. However, tidal turbine may harm fish, whereas wind turbines will not. That brings us to the end of question number 1, and I will see you in question number 2.